For a long time, some phenomena have baffled even the most brilliant scientists. But exactly what are they? Are these occurrences a sign that intelligent life exists on other planets? Come along with us as we investigate the startling discovery of possible city lights made by the James Webb Space Telescope, which has the potential to alter our comprehension of the universe. Earth is the only planet where life is known to exist at this time. Humanity has pondered the possibility of life elsewhere in the universe ever since the beginning of civilization. The search for extraterrestrial intelligence, SETI, project was started in 1984 by American astronomers Jill Tarter and Thomas Pearson in an effort to answer this question. This not-for-profit drive plans to distinguish spaceborne radio transmissions, which are bound to be gotten by the 42 radio telescopes that make up the Allen Telescope exhibit in California's outpouring mountains. Radio waves are liked because of their capacity to travel immense distances with less scattering contrasted with different kinds of radiation. However, no verifiable alien signals have been discovered despite 30 years of searching. The James Webb Space Telescope, which effectively sent off to help this journey, is presently looking at far-off, unseen planets circling faraway stars. As the world's biggest telescope, arranged around 1 million miles from Earth and furnished with profoundly delicate finders, making pivotal discoveries is ready. Planets beyond our solar system were unknown 20 years ago. From that point forward, north of 4,000 exoplanets have been found circling different stars. There may be trillions of exoplanets in the universe, according to NASA estimates. The discovery of plant life on distant worlds may have provided the earliest evidence of extraterrestrial life. For instance, the vegetation red edge, VRE, biosignature, which is a combination of red and infrared light that plants reflect, was clearly detected by the Galileo spacecraft while it was traveling to Jupiter. A planet shrouded in vegetation similar to Earth's wildernesses would transmit areas of strength for a sign. The JWST will measure VRE on distant planets that resemble Earth and are located in the habitable zone around stars. These planets' atmospheres may contain life, which could provide important clues. By dissecting the light going through a planet's air when it crosses before its star, the JWST can distinguish missing frequencies by means of spectroscopy. The JWST is able to detect a distinct fingerprint created by the specific absorption of wavelengths by atoms and molecules in the atmosphere. This fingerprint enables researchers to infer the composition of the atmosphere and the possibility of life. Earth-sized planets with climates wealthy in oxygen, nitrogen, and carbon dioxide are viewed as great contender forever. Identifying innovative life could include finding synthetics like chlorofluorocarbons, CFCs, which would be clear from Earth's climate whenever saw from a remote place. The presence of such synthetic compounds would recommend a development. Life on exoplanets could contrast essentially from life on the planet. Extremophiles on the planet, for example, microorganisms that endure outrageous intensity, cold, or causticity, represent the variety of life shapes that could exist somewhere else. In any case, planets with outrageous temperatures or acidic circumstances are less inclined to help life contrasted with those with additional mild environments. Planets that support life would be ideal candidates if they orbit stable stars and have temperatures suitable for liquid water. While our Sun is a yellow G-type star, red small stars, which are more normal and cooler, offer a superior possibility concentrating on planets with longer life expectancies, permitting additional opportunity for life to develop. The TRAPPIST-1 planetary system, which contains 7 rocky planets the size of Earth and revolves around a tranquil red dwarf star, will be the primary focus of the JWST's initial mission. There may be liquid water on 3 of these planets, which are located in the habitable zone. Proxima Centauri, a red small star 4.25 light a long time from the Sun, is one more possibility for finding potential city lights past our nearby planet group. Because Proxima Centauri is 600 times fainter than the Sun, a planet must be much closer to it for life-supporting conditions. Astronomers discovered a planet in Proxima Centauri's habitable zone in August 2016 as Proxima b. With a mass that is 1.3 times that of Earth, Proxima b is in the Goldilocks zone, where liquid water could exist under certain conditions. However, Proxima b's close orbit, which puts it just 4.6 million miles from its star, puts it in direct contact with powerful solar winds, which could destroy its atmosphere. It is also thought to be tidally locked, which means that one side always faces the star and the other is always dark. This could prompt outrageous temperature contrasts. Proxima B's surface temperature could change fundamentally among constantly, which could be demonstrative of its environmental properties. In order to determine whether an atmosphere is present, the JWST will measure infrared radiation from both sides of Proxima B. Analyzing Proxima B's composition for gases like oxygen, water vapor, and methane could point to habitable conditions if the planet has an atmosphere. However, the JWST has impediments in identifying unbonded oxygen, a solid evidence that something is going on under the surface. Future ground-based observatories, for example, the very enormous telescope booked for the mid-2020s, could give more thorough air examinations. Up to that point, the JWST's discoveries will be instrumental in molding how we might interpret exoplanetary climates and the potential forever. Future space telescopes might utilize progressed methods to shut out the mind-boggling light from have stars and better notice light reflected from planets. Our ability to spot features on distant planets could be improved by this strategy. By and by, many gases created by life on Earth can likewise be produced by non-organic cycles like methane from the tucaos and volcanoes. Exact discovery of outsider life will require knowing among biosignatures and different cycles. As space experts keep on investigating, they might experience misleading upsides and must completely examine planetary circumstances to affirm the presence of life. The James Webb Space Telescope's fundamental information offers a brief look into future disclosures. Whether life exists somewhere else in the universe stays perhaps of science's most convincing inquiry. The response could uncover whether life is far-reaching across the universe or, on the other hand, in the event that Earth is genuinely alone in the tremendous region of room. Humanity would need to make profound psychological and philosophical adjustments in either scenario. This phenomenon has perplexed even the most accomplished scientists. Be that as it may, what precisely is it? Are these baffling lights a sign that another planet has intelligent life? Come along with us as we investigate the startling discovery of city lights made by the James Webb Space Telescope, which has the potential to alter our understanding of the universe. Despite the fact that Earth is currently home to the only known species of life in the universe, people have long considered the possibility of life elsewhere. The American astronomers Jill Tarter and Thomas Pearson started the search for extraterrestrial intelligence, SETI, in 1984 to answer this age-old question. This non-profit organization wants to find signals from space. It focuses on radio waves because they can travel great distances with less dispersion or absorption than other radiation types. There have been 3 decades of dedicated research, but no evidence of alien signals has been found. Notwithstanding, the effective send-off of the James Webb Space Telescope has revived this journey. Situated around 1 million miles from Earth, this colossal telescope, furnished with profoundly delicate instruments, is entrusted with looking at a large number of far-off, beforehand unseen planets circling stars a long way from our planetary group. 20 years ago, there were no planets outside of our own solar system that we knew of. In any case, from that point forward, more than 4,000 exoplanets have been found. According to NASA, there could be trillions of such planets in the universe. The main signs to life past our planetary group could emerge out of extraterrestrial vegetation. For example, the Galileo rocket, while in transit to Jupiter, turned its instruments back toward Earth and recognized an obvious indicator of vegetation through the vegetation red edge, VRE, biosignature. A mix of red and infrared light reflected by plants. On the off chance that an Earth-like planet were shrouded in thick wilderness, it would display areas of strength for a VRE signal. The James Webb Space Telescope, JWST, is going to measure the VRE of distant planets that look like Earth and are in their stars' habitable zones. These signs could be basic marks of life inside the climates of exoplanets. At the point when a planet passes before its star, the JWST might distinguish the light as it enters the planet's environment. Spectroscopy would then uncover any missing frequencies in the light, as iotas and particles in the environment retain explicit frequencies, making a remarkable unique mark that the JWST can distinguish. The composition of the atmosphere can be looked at using this method to see if the conditions could support life. Earth-sized planets with airs like our own, wealthy in oxygen, nitrogen, and carbon dioxide, are reasonable contender forever. We might find evidence of technological life by looking for unusual elements. Chlorofluorocarbons, CFCs, which are used in cleaning products and refrigeration, would stand out if they were found in another planet's atmosphere, just as they would if extraterrestrials were watching Earth's atmosphere from afar. Surprisingly, it's possible that life on exoplanets is not at all like life on Earth. Some organisms, particularly extremophiles, microbes that thrive in extreme environments unsuitable for most life, can appear alien even on Earth. Some can get by in temperatures as high as 250 degrees Fahrenheit, while others get through outrageous chilly, high acridity, or even poisonous conditions. Notwithstanding these conceivable outcomes, Earth-like planets are bound to hold on to life than those with outrageous circumstances. The best possibility for life might be planets with stable stars and surface temperatures that permit fluid water to exist. Our Sun, a yellow G-type star, is somewhat uncommon and has a more limited life expectancy contrasted with different sorts of stars. Red dwarf stars, which are more common and last longer, give life more time to grow into complex organisms. The JWST's most memorable mission will zero in on the TRAPPIST-1 framework, situated around 40 light-years from Earth. There are 7 rocky planets the size of Earth in this system that revolve around a tranquil red dwarf star, 3 of which are in an area that is habitable. Proxima Centauri, the star closest to our solar system and just 4.25 light-years away,